Hi, how you doing, everybody? You see my shirt? I definitely have problems. Okay, anyway, um, okay, so here we go. We just had a multiple computer issues, and then because of that, I forgot that we had to start taping, and then I didn't. All right, so there you go. There's the parent function. Sine is two bowls, cosine is the Karate Kid. All right, and then we memorized these positions, and then I just shared with the students that now we're going to change the period and the amplitude. The parent functions, it's 1 sine 1x. A is a stretch shrink factor. B actually stretches and shrinks horizontally, which changes the period. Period, the word means where does the sine curve end? And then it starts repeating itself. Feels nice in here now, doesn't it? Okay, so here's what we're going to do. On your worksheet that I just slapped at you today, I'm having you graph two periods, right? But if I gave you a book assignment, they often just say graph one period of this, which usually means just graph to the right of the y-axis. So if it just said 3 sine x, b is 1, 2 pi over 1 is the period. This is where the sine function will end. Now listen to my fractions here. This is super simple. And I forgot to check if my sound is working. Arr, I didn't used to have to do that. So if this is not, if I don't have any sound right here, you won't know what I'm saying when I'm waving my arms right now. And this doesn't have near as much value as a video. Oh, the technology. Okay, so here we go. What is half of 2 pi? Everyone, 3, 2, 1, go. Pi. Hey, what is half of pi? 3, 2, 1, go. Pi over 2. And then listen to what I say on this because it's going to get rough after this. 1 pi over 2. Watch. 1 pi over 2. 2 pi over 2. Anyone? 3 pi over 2. And then what's the last one? 4 pi over 2. Is that 4 pi over 2 at the end? Yes or no? And what I've just noticed or made you notice is pi over 2 is the 1/4 value of the period. Just watch that. Now I know we had these already. You had these up in the parent function fumble because this is not a different period than the parent. All right, so therefore we're fine. Now the parent function. Let's draw what the parent function should be: 1 and -1. But there's a 3 in front. So let's just think about this. For sine, just humor me for a second. This is the y, if you care. Just let me do this for 5 seconds for those that connect with me on this. Sine of pi over 2 is 1, right? Right? Whoever's connecting with me. Jacob's looking at the ceiling tiles right now. I'm not listening to this. All right? Sine of pi over 2 is 1. 1 times 3 is what, everybody? 3, 2, 1, go. 3. That's why this point changes from 0, 1 to 0, 3. There's the stretch. But here's the thing. What's sine of 0? Still 0. What is 3 times 0 still? 0. So that point doesn't change. All the points in between all get stretched by a factor of 3. Still the highest point will be 3. All right, because sine of pi over 2 is the highest evaluation value. Sine of pi is still 0. 0 times 3 is still 0. Sine of 3 pi over 2 should have been -1, but then multiplied by 3. This is the y. This is why there's this stretch. And then sine of 2 pi is still 0, which ends up back at the origin. That's wrong. Back at the x-axis. I don't know why I said origin. Sorry, my hand was in the way to finish that sketch. And then it'd be real easy to draw a second period. You just cut and paste those values, but make them negative. Negative pi over 2, negative pi, -3 pi over 2, and -2 pi. And then you keep the graph going and make the dots. And then there would be your second graph, right? So 2 periods is not a big deal. Next. Oh, no. I have this various questions here, and I'm actually keeping this to graphs where only the amplitude is changed first. Because yet again, the period is still 2 pi over 1. But you do have an A value of 4, which is a stretch of 4. But what does that negative do on the inside? Is that an x-axis reflection or a y-axis reflection? Try to remember this from chat last semester. 3, 2, 1, go! I hope you listen to him. There was only one person. It's a y. Can kind of explain this. And then we're not going to do what we did with the last one. Guess what? On your worksheet, isn't there one tick mark above and below on the y-axis? Just make it 4. Just label it as 4. We're not going to do 1, 2, 3, 4 and really show units and all that other stuff. You don't need to. Okay, now, here's the cosine. Sorry. Were these both sine, by the way? That first one was sine, right? I'm surprised I didn't do a cosine there. Since the period's 2 pi, this is 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. Remember that when I start changing the period. And the only thing that you're almost going to faint on today is fractions. It's going to happen again when I go through this fractional, how you break down the x-axis. And those whose brains are going to overload, it's because you're still stuck in 4th grade mode and you can't figure out how to deal with those things. Oh, I'm tripling down on that because it is exactly what happens with radian values. It is only 4th grade fraction stuff. And we need to really get good with that. And by the way, if I was doing 2 periods, cut and paste. All right, but now imagine a y-axis reflection. This would have been the graph. This would have been the graph because it's sine bowl bowl. Okay, but then this would have been the graph over here. When I y-axis reflect this bowl gets reflected over here and it's actually upside down. So actually, this is here, then here, then here, then here, then here. So it looks like what we would call an upside down sine curve. But if you look at that dotted part that I created before the reflection, this dotted bowl does slap on top of this, and then this one does slap on top of that. So think of a y-axis reflection and how that would look. Another way you could discount double check input, say it. You have to know this though. I plug in pi over 2. You have to be really good with your evaluations. When I plug in pi over 2, it becomes negative first. Negative pi over 2 is actually negative 90 degrees, or at 270. The sine of that is negative 1, not 1. Negative 1 times 4 is negative 4. Booyah. All right, it is exactly where I'm supposed to have that. That's people that actually go above and beyond being a robot and trying to just get right answers for Mr. Samuelus. That's true understanding. Now, this mirrors what the worksheet has a lot of times. I actually have to change something in this. I do want to add something to one of these examples. So this one I'll say sine again. Do I have any cosines for the? There we go. Nice, 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 nice. Okay, so 2 sine 3x. First of all, what's the amplitude, everybody? 3, 2, 1, go. 2. It goes, remember what amplitude is. It does go 2 to negative 2, which is a distance of 4 y-axis values, which actually half of that is 2. It's always half of the y-axis distance. Something else I should have been doing is domain and range. Let me do that on this one. I'm not going to revert back. So domain and range will happen on this one after we're done. Let me make sure I put that down here. Domain. Oh, gosh. Range. That wasn't a computer. That was me. Well, it is a slippery screen, but. Okay, so domain and range. All right. So notice what it said. 2 periods now. This is exactly like your worksheet. All right, now I'm telling you, remember I tripled down and it became fractional jerk man because it really is the fractions that's going to stumble you here. And you know what? Let's just call that 2 and negative 2. There is no reflections. So that's good. What's the period? Well, the period is just 2 pi over whatever that b value is. 2 pi over 3. Now, I will tell you what this does comparative to our last question, which was a sine curve as well. I will graph this little picture next to the one that I had before. But you don't have to worry about that. All you got to do is say, okay, since the period is 2 pi over 3, a sine curve will be done at that position. Got it? So it'll be done there. Remember what I did with 2 pi? What was half of 2 pi? What did you put there? Just tell me with the last question. What's half of 2 pi? Pi. Okay. What is half? This is why I want to cry on the inside. This is why I cry myself to sleep at night. Students that still cannot answer this question super fast. So I'm going to write it really large. What is half of 2 pi over 3? By the way, the 2's cancel for the love of dog. And what is the answer? 3, 2, 1, go. Pi over 3. All right. Again, this should not be a reason why CAT students are stumbling. This idea about fractions and the ability to cross cancel. All right. The 2's cancel. This is so simple to say it is 2 or pi over 3. And I've showed this a million times in my class. So that's my frustration level at this point with those that say radians are impossible. You are still telling me 4th grade that you cannot do fractions. What is half of pi over 3? 3, 2, 1, go. See, no one's answering. It's still a problem. You have got to be able to envision this. And then what do I do with the denominators? Multiply them. So I ask one more time, what is half of pi over 3? Pi over 6. Now, what I don't like my spacing there. So I'm already going full boat, jerk mode, because this is the stuff, not cats. This is the stuff that's crushing people. By the way, remember what I did before? 1 pi over 6. 2 pi over 6. Isn't that true? What's 2 pi over 6 reduced to? Everyone just say it. 3, 2, 1, go. Pi over 3. No one's saying a word. They're all mad at me. I don't care. Let's move on. 1 pi over 6. 2 pi over 6. What's next? 3, 2, 1, go. 3 pi over 6. What's 3 pi over 6? What's 3 pi over 6 reduced to? If you feel free to write this down to get your fraction mind going, then go ahead. My pen was being a jerk there. Wouldn't let me write that. So 1 pi over 6. These are all pi over 6 away now. These little spaces here. That's why I'm doing this adding to find the third of the 4th positions where I have my key components of this graph. So 1 pi over 6, 2 pi over 6, 3 pi over 6. Is this 4 pi over 6? Yes or no? 4 pi over 6 reduces to, say it, 2 pi over 3. Because you don't say it, then you're just telling me that you're just not going to get this figured out. Then you're going to write a little passive-aggressive note on your next quiz. I don't understand any of this. It's your fault. This pen is, oh my gosh, can't wait. I just had the technology I had in 2013, I'd be fine. And now you graph sine. So how does sine graph? Let me get this out of the way. Sine starts at 0. Let's do a different color. Then it goes up to the high point, back to 0, back to the low point, and then back to 0. Bowl. Bowl. And then it continues on. And then here, I'm going to go through that there. So a common misconception is maybe like going back up to the high point, and then they have a sine curve. Nope, it keeps flowing, and then this goes down to the low, back up to the high. Okay, so this is a second period's worth. And there's 2 sine curves, 2 periods worth, 2 cycles. Sometimes they call it 2 cycles worth. All right, so let's get going. Do you want to get nuts? Let's get nuts. Yeah, I don't like that button on my... Okay, so we're going to go ahead and graph 2 periods again. So we quickly snap this, and then honestly, you could just hit 4 and 4 because it's the 4 positions that we have here. First of all, what's that negative do on the outside? What does that flip it over, the x or the y-axis? 3, 2, 1, go. The x-axis. What happened to you guys? What's 2 plus 2? 3, 2, 1, go. 4. You didn't answer one question yet. How come no one's answering questions? Was I that bad? Is it because I've been so mean you're not going to answer anything? Wake up. Right? That's a good song. That's from the Foo Fighters. Anyone know that song? No. Run for your life with me. Wake up. All right, here we go. It's actually a really good song. Okay, so now, what is two? What is 2 pi over? Should I get rid of my face? No, move it. Let's move it. 2 pi over 1/4. What is 2 pi over 1/4? What is dividing by 1/4 the same thing as? Multiplying by 4. So what is 2 pi over a fourth? 8 pi. So guess what this is? Got sabotaged again. Just a feature that I wish I could turn off, but I can't. In 2022. What is half of 8 pi, everybody? 4 pi. What is half of 4 pi, everybody? 2 pi. 4 pi. Say it. 6 pi. This is as hard as it is to do these questions. Okay, I forgot. And I forgot to do domain and range in the last one. I'll do it on both. And then I forgot that I was going to put like these up to our original graph and what would be the difference. Okay, and it is massive when you try to compare these three. That's why we don't really often do that. Okay, so this is negative 8 pi. This is negative 4 pi. This is negative 2 pi. This is negative 6 pi. All right, it's just the two periods is the simplest thing to do. You just cut and paste. All right, now you're just going to mark this as 5 and negative 5. And then it's the cosine kid, but it's flipped upside down. So actually what I should do is make you answer questions. I think I'm going to do this tomorrow. But my question would be 0, comma. What would I write? Would it be 0, comma 0, 0, comma 5, or 0, comma negative 5? This is going well in fourth hour. 3, 2, 1. Which one is it? Oh, at least a couple of people answered, but it was not correct. It's the cosine kid, which is supposed to start at the high point and then go like this, but it's flipped. So one more time, 0, comma, 3, 2, 1, go. Negative 5. Then I asked the student 2 pi, comma, what would be the answer? 5, negative 5, or 0? 0, because now we're starting to flow back and come to this way. Everyone should get this one right. Then therefore it'd be 4 pi, comma, 3, 2, 1, go. 5. And then 6 pi, comma what? 0. And then 8 pi, comma what? Not 5, negative 5. And then negative 2 pi, 0. Negative 4 pi, 5. Negative 6 pi, 0. Negative 8 pi, comma, negative 5. There's an upside down cosine kid. Yeah, kind of hard to draw, right? And there's another upside down negative cosine kid. See, that's what you got to visualize. Hi-ya! Cosine kid, but flipped. Like this, but upside down. Okay? And that's what we see and we recognize. Okay, I forgot to do domain and range. Domain, for all of these, I think you could surmise, is all real numbers. I can trig any number and get an output value. But the range is definitely affected. The range for this one only goes from negative 2 to 2. That's the high and the low point, respectively. This one, same. Domain is all real numbers. All of these would be all real numbers. Wait till you get to tangent, cotangent, secant, and cosecant. Things change. The range, this one goes from 5 to negative 5. So that's how you have to write it. And it does include the 5s and negative 5s because those are hid as values. But I really wanted you to see, like this one, I really like this one. Too high, but it ends at 2 pi over 3. And that was a sine curve. How does that look different compared to this one? Well, first of all, it's only too high. Don't do this, just watch. All right, and then I did want to show you that the period of the last one was 2 pi over 3, which is 1/3 of the way. So here's what this picture right here, this blue one, would look like on this coordinate plane. It would only be too high, and it would end like 1/3 of the way. And I'm actually going to do a couple of these. So this is what this sine curve would look like compared to this one. Do you understand? You see that? Not as high. And actually 1/3 of a sine curve is already completed. Because I also want you to know something else about that 3 in front of there. Notice when I do another sine curve, here's 4 pi over 3. Here's 6 pi over 3. How many sine curves do you see here? 1, say it. 2. How many do you see total? 3. That's another incarnation of what that number means. You should see 3 sine curves completed up to 2 pi. That's why you see a sine curve finished 1/3 of the way compared to 2 pi. So a couple things to know about that one. If I threw this one on that graph, first of all, it's stretched like really large, and this is only 2 pi. You'd only have 1/4 of the sine or cosine curve even showing right now. I think you'd only see from -5 to this 0 right here, and that's all you would see because it's not even close to being completed yet. So I want you to understand these together. You don't have to worry about that ever. But I do want that understanding factor. All right, and then, here we go. This is where I get real jerky with the fractions. Okay, so first of all, the amplitude is 4. All right, I should make you answer questions, but I won't. I'll leave you be. But this fraction stuff, oh gosh, how long this has been troubling us students here. Because the period is, I made this ugly on purpose. 2 pi over 7. That means 7 cosine curves will be completed up to 2 pi. You don't have to worry about that. On your worksheet, I just have this. I actually should have done something else, but I won't. I do. I actually have time for it, and I will. Hey, what time do we get out of here? Maybe I don't. All right, because I do have to go to those reverse analysis questions. I guess I could do one that's on the worksheet and tell you what the period actually is when pi is in the equation. Yeah. Okay, so here's 2 pi over 7. You should eventually be able to do this without writing this down. What is half of 2 pi over 7? Again, I think everyone's angry at me in 4th hour. No one's answered a question. What's half of 2 pi over 7? 3, 2, 1, go. Pi over 7. The 2's cancel. This should be as easy as 4th grade. What is half of pi over 7? 3, 2, 1, go. Pi over 14. It is not rocket science to take half of pi over 7, and we still have a majority of our seniors struggling on that. I know it, because we've dealt with this kind of fractional work, before. Okay, then here we go. Pi over 14. 2 pi over 14. Is that 2 pi over 14 if we know how to reduce? What's next? 3 pi over 14. And just to make sure, is this 4 pi over 14? I don't know why I did that. 4 pi over 14 reduces to 2 pi over 7. So once you get this value, these are all pi over 14 away from each other. You can just keep adding pi over 14 until you get to that 3rd value. This is always how I find the 3rd value. All right? And then you just cut and paste for 2 periods. Now let's go like that. 2 pi over 7. Pi over 7. I hope this sound is on. Pi over 14. 3 pi over 14. So it doesn't matter. Oop, I didn't put that 14 there. Kind of hard to squeeze these in there. Probably would be nice to have more space. And then all you do is go up 4 and down 4. Amplitude's easy. Just mark it. Just mark it on the y-axis. Just make sure. Okay, and then it's a cosine. So it's a cosine kid. This is the first thing I'd ask you. 0, comma. Is it 0, comma 4, 0, or -4? 3, 2, 1, go. Nothing in 4th hour. It's the high point. So we're up here. Next thing, what's pi over 14, comma 4, 0, or -4? 3, 2, 1, go. 0. It's pi over 7. You getting ready? Are you cold now? Are you cold now?
Well, I had it on the whole
Oh,
time.
okay. All right. What's pi over 7 equal? 3, or pi over 7, comma 3, 2, 1, go. -4. Thanks, Santino. And then 3 pi over 14, comma, what? And then 2 pi over 7, comma, what? Okay, that's how you get the cosine kid from yesterday's stuff. Now the period has changed. Try to make it a nice smooth curve. See how at my old age I got a little wrinkly there. And then I'd ask pi over 14, comma 0. Pi over 7, comma -4. 3 pi over 14, comma 0. And then 2 pi over 7, comma. Might have a little, little exercise tomorrow on this. Bouncing around the room and making sure that we know what we need to know as far as getting these graphs done. Absolutely. Okay. All right. And then again, the domain is all reals. Silly. Range is -4 to 4. Again, very simple on the range because that's all that's covered. Notice how my cosine things are. They loop around, right? They don't go off into space. They loop around and come back down. Ooh, that rhymed. Okay, and then on the back of your worksheet, they have questions like this. Got no time. Got no time. Got no time. There's this picture. By the way, what does this look like? Does it look like a sine or a cosine? That is a sine. So number 1, you pick sine. So this is reverse analysis. You might just have to just watch this as we have our last couple minutes here. Number 2, what is the period? What is the period? I just circled that nut thing. What is the period? 3, 2, 1, go. Pi. So I have one complete curve. Or if you remember what I said about how many sines do I see, how many sines do you see up to 2 pi? How many? 2. So what is this number right here? It is 2. It's not 2 pi, it's 2. All right, it's just 2 in that equation. Oh, by the way, what is the amplitude? How high and how low does this go? 2. And then what's one more thing that I'm missing? What kind of sine curve is this? This bowl is like this and like this, when it's supposed to be like that. So what should I throw in front of this? A negative. This is reverse analysis of looking at the picture. What is the equation? All right. So that was a kind of a thing. I wanted to show this though on period. I could switch these two. If I know the period, then I can switch that with B and find what B is that belongs in the equation. So I know I'm short on this. I love that I had 5 minutes of technical difficulties here. So we'll end with this one. By the way, as you're packing your stuff up to 2 pi, what do you see here? Do you see cosine or sine, first of all? Is that cosine or sine? Do you see all of it or what fraction of it? You see half of a cosine. So that means the period is actually 4 pi. So that means this is y equals 3 for the amplitude. Cosine, I saw half of a cosine curve. So actually that works for that half in there. Or if I put 2 pi divided by half, I do get 4 pi as my period, not as my b value. All right, that was just saying that if I extended the x-axis, this is where I would end up at. Worksheet due tomorrow. There may be a couple questions in the back end that you might not be able to do. I'll definitely check that front, though. Oh, 4th hour, not answering questions.